Our next congruency theorem to show that two triangles are congruent is called hypotenuse leg. All right, so we see that word hypotenuse, so we know this will only work inside of a right triangle. So if the hypotenuse and one of the legs of a right triangle are congruent to the hypotenuse and the leg of a second right triangle, we can say that the two triangles are congruent. All right, and just a reminder, and I'm going to zoom in on this picture, when you're dealing with a right triangle, the side opposite the 90 degrees is your hypotenuse, and then the other two sides adjacent to the 90 degrees are your legs. So this comes from the Pythagorean theorem. This is basically just an extension of side, side, side when we're dealing with right triangles. So determine if hypotenuse leg exists. In example 3a, we've got right triangles there. We've got the hypotenuses, so we've got AC congruent to DB. All right, that's given to us. That's our hypotenuse. And we notice BC is congruent to itself. It's a shared side. BC is a shared side, and that's a leg. So therefore, yes, these two triangles are congruent. Let's write a congruency statement. Let's make sure the order works. So if I start with triangle A, B, C, my second triangle, if I go from A to B to C, my second triangle needs to be triangle DCB. That way all of the congruence, all of the corresponding parts match up. All right, the order is super important with your congruency statement. All right. What about in 1 or 3b? We've got 90-degree angles here. AC is congruent to itself because that's a shared side. All right. So I've got these. Do I have any legs? No, I don't have any legs that are congruent. All right. So no, not enough info. Not enough info there. All right, let's get into a formal proof. Okay, use the HL theorem. I'm telling you that WY is congruent to XZ. WZ is perpendicular to ZY. XY is perpendicular to ZY. And I'm asking you to prove that the two triangles are congruent. Now, this can look complicated because these two triangles are literally overlapping each other. All right, so one thing that I might do to help out is draw them separately. Draw my simpler diagram, okay? That way I can see these two triangles separately and I can understand what's going on. All right, that's not saying the original overlapping diagram won't be helpful because it might help us see some things. All right, but when I start needing to mark these up with congruent tick marks or angle swoops, drawing them separately is going to be helpful. All right, so I'm telling you WY is congruent to XZ. WY congruent to XZ. All right, so I'm going to list that. I'm going to list that as one of my reasons. WY congruent to XZ. That was given to me. All right, but notice how that's the hypotenuse. I already got the hypotenuse congruent. All right, because you can see with these other two givens, sorry, I kind of jumped the curb here on this diagram. With these two statements that WZ is perpendicular to ZY and XY perpendicular to ZY, I have two right triangles here. All right, so I am already dealing with right triangles. That opens up the gate so that I can use hypotenuse leg. One of my givens, WY congruent to XZ, tick marks, already tells me that I've got the hypotenuse congruent. So now I just need to figure out, okay, why is one of these legs congruent to each other? All right, is there anything that shows me that WZ and XY are congruent? Maybe not. Okay, what about the other leg? Well, notice that the other leg is ZY. Notice ZY, let's do this color. ZY is shared on both of my triangles. So ZY is congruent to itself because it's a shared side. Or formally, we say because of the reflexive property. It's congruent to itself because it's the same side that's being shared between both of my triangles. Well, that right there, that's your leg. Okay? So YR triangle, whoa, bad triangle symbol. Triangle WYZ congruent to triangle, whoa, what am I doing? Sorry, getting ahead of myself, getting too excited. So, Y is triangle WYZ congruent to triangle XZY. Well, notice what I have written right here. Because of the hypotenuse leg theorem. All right, so I just kind of list a bullet point of what I can tell based off of these diagrams, and I'm going to be able to match it to a congruency theorem. Okay, in the next couple videos, we will dive into different theorems. There's 3 more, I believe, that we're going to talk about. All right, but that's why it's so important to list what you have over here and to draw your diagrams and mark them up. That way, you can know for sure what type of theorem you're dealing with. Okay? So, next up, last little statement before we move on. So, if we prove that 2 triangles are congruent, so like, for example, if I prove that triangle ABE is congruent to triangle DBC, and my reasoning is either side, 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 or hypotenuse leg, or one of the theorems we'll deal with tomorrow or in the future video. So I'm just writing these down for right now. You don't know what these are, but that's okay. So if your reasoning for your triangle being congruent is one of the theorems we're going to talk about, then you can say, once those triangles are congruent, AE is congruent to DC because of this reasoning right here. If we have congruent triangles, then the corresponding parts in those triangles have to also be congruent. All right, it's wordy. The corresponding parts of congruent triangles are congruent. All right, I'm not going to have you write that out every time. You can abbreviate it. We commonly refer to it as CPC-TC. Okay, corresponding parts in congruent triangles are congruent. All right, so use this and work through these 2 you try nows. Try your own proof. We'll go over it together in class. All right, and then try out number 2. Proofs require a lot of practice and a lot of critical thinking. Make sure you're in the right mindset when we're doing these, okay? You're extremely capable of doing them. They just require practice so you get used to seeing what you're seeing. Let me know if you have any questions. Try these you try nows and then start your practice problems.